All right, understanding sampling distribution for means. So it says, let's start with a very simple example. Let's say there were only 4 people who took a test. It's the same test we referred to on day 1. We're going to use it again on day 2. Let's say only 4 people took it. And there's their scores, 60, 70, 80, 90. Take a sample of any 2 of the scores, find the mean. So just on your paper right now, just pick 2 of those. Don't tell me what it is, just pick 2 of them, add them up, divide by 2. Find the average. Go. Alright, I'm going to skip to 1 and go to 2 because in number 2 it says figure out all the possibilities and then calculate the mean. So that would be, wow, whoopsie. That would be, okay, well, we're just going to start. Alright, so all the possibilities, that would be adding 60 plus 70 and dividing by 2, 60 plus 80 dividing by 2, 60 plus 90 divided by 2, and then 70 plus 80 divided by 2. So again, you really shouldn't need a calculator for this. Halfway between these 2 is 65. Halfway between those 2 is 70. That's 7. Halfway between these 2 is 75. And halfway between these 2 is 75. Okay? So those are the 4 different possible means. Okay? Those are all 4 combinations. Now, it says make a dot plot using each of these means you found. So we're going to put 1 dot at 65, 1 at 70, and 2 at 75. Okay? Those are all 4. We got 70 and 90. So 70 plus 90 divided by 2, and that would be 80. So we have 1 right here. And 80 and 90, I forgot that one too. I knew it wasn't distributing right. 80 plus 90 divided by 2 will give us 85. Look at that beautiful distribution. Almost like perfect. You can see a little. Okay? There's all our possibilities right there. Now, the dot plot is called a sampling distribution. It shows the means calculated from all the possibilities. That's very key. Okay? A sampling distribution has to have every single possibility. And eventually I got all the possibilities up there. So, moving on. We're going to take our calculators. And we are going to do what we did in the previous lesson. We're going to go to Stat, Edit, and put all of those in. I already have it there. Go ahead and put it back in yours. Now, we need to do some random number generating. So, put a 1 here. If you want to, go all the way through, but if you can figure it out and just count, 1 to 10, 11 to 20, and then 21 to 30. If you have to put in, 2, 3, and so forth, go ahead and do that. But if you can kind of figure out and just count with those as your guide, that'd probably be the quickest thing to do. So, what we're going to do is we're going to take our calculator now. I have a question. So, just a reminder, we're not finding the average. We're not running one variable statistics on all the data. That's what we did yesterday. If you want that answer, you just look back to yesterday's notes. We're going to be sampling 5 random numbers. So to do that, remember, we have to hit Math, go over to PRB, hit number 5, okay? And we have 30 numbers, and we're going to pick 5. It didn't happen. It didn't work. Let's do this the right way. So we're going to hit Math, Random, 5, from 1 to 30, and we want 5 numbers. Okay, so I got 28, 5, 16, 13, and 23. So I need to look now at my numbers and figure out the 28th number. So this is going to be different for everyone in here. I got 28. So for me, 28 is right here. That's the 28th number. So 77. And then my 5th number is 4, 5, 81, right here. My 16th number is 12, 13, 14, 15, 16, 79. And then 13th number is 60. And my 23rd number is 88. Those are my 5 random numbers. Now I'm going to go into my calculator and put in those numbers. Okay, so 88 plus 60 plus 79 plus 81 and 77. 81 plus 77. And I'm going to divide by 5. And that gives me a mean of 77. Okay? That's the average of those 5 random numbers. Okay, so now what you're going to do, after you do that, you're going to do it 4 more times. Okay, so you're going to get 5 random samples. So you're going to get these numbers. You're going to run the random generator 4 more times and find those numbers and put them on here and find those means. All right, so I ran my generator 5 times. These are the numbers I got. Those are my averages. Oddly enough, I thought this was happening, and it happened all the way through. My averages actually went up consistently, slightly. Just random, but it's a weird coincidence. So those are your my values. I'm going to put this up here, and then everybody's going to come up and put their 5 values. So we should have close to 100 dots on here once we're done. I'm not going to record it by doing it. I'll just get the result. All right. So that's our 100 dots, or approximately. There's 20 people here, 5 each. That's approximately 100. All right. All right, so what does each dot represent? Each one is a sample mean or average. Okay, each one of those was a sample mean. We took a sample of 5 and found the average. So each dot represented a mean of 5 samples. Now remember, a sampling distribution, we already said that, shows the calculated means from all the possible sizes of 5. Is the above dot plot, or the previous page, a sampling distribution? And the answer is no. There are many more samples. There are many more samples. That is not every possible sample of 5. Okay? There are hundreds, if not more, thousands of samples. So that is not sampling distribution. It's just a dot plot of the ones we found. All right, let's say we took a random sample of 5 test scores at Eureka and got a mean of 68. Is this convincing evidence that Eureka students did worse than the students at our school based on our sample? Now remember, I think when we ran this on the previous day, we got an average of like 88. All right? And you can see where our numbers were, you know, just our samples, all pretty high up there. In fact, the majority of them were, you know, between 76 and 95 or so. Okay? So does the 68, if we took that at Eureka, mean they did worse? No. Not enough data. Not enough samples. Okay, one sample of 5 is not enough. Okay, we just did 100 of those. just taking one random sample is not enough. If you look at what we did just in this class, look how the majority was way up there, but we did have this one down here at 62. We had a few in the low 70s. So that could have been that one sample from Eureka. It's not enough data. And again, sample distribution is a sample mean, so this is just a reminder, this is just a restatement, X bar. Okay? And again, it's all the possible. So that's it, and the homework is page 406, 5, 6, 8, 11, and 12.